Imagine you're driving 70 miles an hour down the highway,
Right.
and you suddenly realize you need to swap out your car's engine.
Sounds incredibly stressful.
Right. And, oh, you don't have a manual. Also, if you mess up, like, the global economy might take a hit.
Yeah, no pressure at all.
Exactly. I mean, that is the terrifying everyday reality for the enterprise leaders, the CIOs, the tech-curious folks tuning into this deep dive right now. You're wrestling with these massive, incredibly complex, well, decades-old systems, honestly.
Yeah, they run everything.
They really do.
Yeah.
We're talking the hidden architecture that processes global banking, manages healthcare data, routes supply chains, and you absolutely have to modernize them. I mean, the market demands it.
You don't really have a choice anymore.
You don't. But the billion-dollar question is, how fast can you actually move without breaking the very things that already work?
Well, it's the ultimate executive tightrope walk, really, because on one side you have this intense pressure to accelerate. Like if you don't modernize, you just stagnate.
Right. You just bleed competitive advantage to those digital native startups.
Exactly. But on the other side, if you move recklessly fast and disrupt a mission-critical workflow, I mean, the consequences aren't just a minor inconvenience.
Oh, no. They're catastrophic. For revenue, for reputation, everything.
Right.
Which brings us to our mission for today's deep dive. We're focusing on a single, super comprehensive source today. It's called the Modernization Playbook by Codora.
It's a really fascinating read.
It really is.
Yeah.
And our goal here is to decode why the traditional approaches to modernization are, well, failing so spectacularly across basically every industry.
Yeah, the failure rates are pretty staggering.
Seriously. And more importantly, we want to look at how leading enterprises are using AI-native approaches to eliminate that false choice between speed and risk.
Because it really is a false choice.
Okay, let's unpack this, because the playbook points out that treating acceleration and caution as these two mutually exclusive opposing forces, it's actually a massive trap.
What's fascinating here is that the speed versus risk dilemma only exists because organizations just lack structure.
Oh, really? Not a tech issue?
No, I mean, it's not a technology problem at its core. It's an
Yeah.
information problem.
Okay, an information problem.
Yeah. When you lack a clear, granular understanding of your legacy systems, your dependencies, your business logic, you are forced to guess.
And guessing with a banking system sounds like a terrible idea.
It's a disaster. And when you're guessing, you either move fast and break things, which leads to total instability, or you move agonizingly slow.
Which just leads to paralysis.
Exactly. Total paralysis.
So going back to that highway analogy, that's essentially what the traditional Big Bang modernization approach feels like. Right?
Oh, the Big Bang. Yeah.
Like you're trying to rip out the old engine and drop a new one in,
Right.
all during a single weekend release window.
Just crossing your fingers and hoping for the best.
Right. It's a scenario where literally one tiny miscalculation causes a total disaster.
That's the perfect way to visualize it, honestly. The Big Bang transformation it concentrates all your execution risk into one single terrifying event.
Yeah, but on paper, to a board of directors, it sounds great. Right?
Oh, incredibly appealing. You make a clean break from the old technology, you flip a switch on Monday morning, and suddenly, boom, you're in the future.
But in practice,
In practice, the testing required for a Big Bang release is unimaginably complex. Like, your rollback strategies are severely limited.
you can't just undo it.
No, you can't. And most crucially, it assumes a level of pristine, perfect system understanding that simply does not exist in the real world.
Like having the perfect blueprint.
Exactly. You can't safely swap an engine at highway speeds if you don't even have the blueprint for how the engine connects to the transmission, you know?
Wow. Okay, so the Big Bang is way too risky. But then there's the other extreme the playbook mentions, which is lift and shift.
Right, the classic lift and shift.
Yeah, the idea where you take your old legacy system, you pick it up, and you drop it into a modern cloud environment like AWS or Azure.
Just move the mess somewhere else.
Boom. Modernized. Except, well, the playbook says that's basically a mirage.
It creates a very dangerous illusion of progress, honestly.
How so?
Well, you're moving to modern infrastructure, sure, which might give you some short-term gains in raw scalability, but you aren't fundamentally changing the application architecture.
You're just changing the server it lives on.
Right. You're just preserving your technical debt in a shinier, much more expensive environment. You leave modern cloud infrastructure supporting outdated, inflexible code.
Ah, I see.
It's literally like taking that old, sputtering 1990s car engine and bolting it into the chassis of a brand new Tesla.
That sounds ridiculous when you put it like that.
But that's what companies do. You haven't solved the core problem, you've just moved it.
And to try to manage all this chaos,
Yeah.
IT teams end up with what the playbook calls fragmented tooling.
Oh, the fragmented tooling is a nightmare.
You assemble this random Frankenstein-like collection of platforms, right? A documentation wiki over here, a legacy code analyzer over there.
A migration utility somewhere else entirely.
Exactly. And none of them talk to each other.
That's where the wheels really fall off. Because each tool operates in its own silo.
Right.
You get totally inconsistent outputs across teams, massive duplication of effort, and most dangerously blind spots.
Just gaps where you have no idea what's happening.
Right. As an enterprise leader, you lack a unified view of your risk. You have absolutely no end-to-end visibility.
And if you're a CTO listening right now, you already know the cold sweat that comes with these endless budget-draining IT roadmaps.
5-year plans that never actually finish.
Right. They stretch out for 5 years and somehow never deliver measurable business value. You just end up spending your entire budget fixing things that broke during the transition.
It's just constant putting out fires.
But wait, hold on. I have to call a timeout and push back on this premise just a little bit.
Okay, go for it.
We are talking about multi-billion-dollar enterprise systems here. Systems running global banks, airlines, healthcare. Don't companies have documentation for this stuff?
You would certainly think so.
I mean, why are we acting like these systems are complete black boxes?
Well, it's the most logical assumption to make, right? You'd think a Fortune 500 company has a pristine manual for its core ledger.
Exactly.
But the reality of environments built on COBOL, which, by the way, is the 60-year-old language powering most of the financial sector.
60 years old.
Wow. Or mainframes running these tightly coupled monolithic architectures. The reality is entirely different.
How so?
Because these systems aren't just built, they're grown.
Grown?
Yeah, they've evolved over decades. Thousands of different developers have touched the code, added patches, implemented quick fixes to meet some quarterly deadline.
Ah, the classic temporary fix that somehow becomes permanent infrastructure.
Spot on. Let's say it's 2004, right? And a developer needs to make a module handle a new European tax regulation. They write a clever workaround, they push it live, and they completely forget to update the official documentation.
Or they just never had time to do it.
Exactly. Over 30 years, that happens tens of thousands of times. So the critical business logic, the actual operational rules that govern how transactions are processed,
It just gets lost.
it becomes completely undocumented. It exists solely within the messy code itself. And that brings up an even scarier point, the demographic time bomb.
Right, the playbook mentions this. The people who actually wrote this code are leaving.
They are actively retiring.
Wow.
The institutional knowledge required to understand these highly specific legacy systems, it exists almost entirely in the minds of a rapidly shrinking pool of experienced engineers.
So all the secrets are just walking out the door.
Pretty much. The global economy is heavily reliant on code maintained by people who are currently enjoying their retirement on a golf course somewhere.
Wait, and if the system breaks, there's literally no one left to call.
Literally no one.
That is terrifying.
It is, and it creates this massive compounding risk, because when you can't see the system clearly, you inherently underestimate its complexity.
You think it's simpler than it is.
Right. Let's look at a hypothetical banking scenario. A modernization team comes in and says, hey, we're just going to rewrite this one simple zip code validation module to allow for international addresses.
Sounds easy enough.
Right, sounds easy. But they can't see that this seemingly isolated module is secretly tied to a core routing protocol from 1998.
Oh, no.
Yeah. They change the zip code format, and suddenly, cascading dependencies are triggered. A critical downstream reporting system crashes, and cross-border payments fail for 12 hours.
So they touch one string and the whole spiderweb shakes and things break that they didn't even know were connected.
Exactly. They literally cannot see the complexity, so they fly blind. And that is why traditional modernization efforts fail before they even really begin.
Okay, here's where it gets really interesting.
Let's hear it.
If human memory is gone and the old manuals are completely useless, how do you even begin to map the system before making a change?
That's the million-dollar question.
I look at it almost like an archaeological dig, you know?
Mm-hmm.
When you find a buried ancient city, you don't bring in a bulldozer to build a new museum on top of it.
No, that would be terrible.
Right, that's the Big Bang approach. You destroy the very thing you're trying to work with. Instead, you systematically grid the site. You use a little brush to clear away the dirt.
Yeah, very carefully.
You map where every single artifact is in relation to everything else. And only then, after you have total clarity, do you bring in the construction equipment.
I love that visual
Yeah.
because it perfectly captures the discipline required here.
You have to be systematic.
You have to systematically map the unknown. In the industry, and specifically in this playbook, this is formalized as the DUM framework.
DUM,
Document.
understand, modernize.
Exactly. It's a highly structured, sequential approach designed specifically to eliminate that uncertainty. Phase 1 is document.
Brushing away the dirt.
Exactly that. The objective is to systematically extract knowledge directly from the source code itself.
Okay.
Whether it's COBOL, Java, or JCL, which is basically the traffic cop language for mainframe operating systems, you are analyzing the actual code to generate comprehensive, factual documentation.
Not just guessing based on what it should do.
Right. You are taking assumptions and replacing them with verified insights derived straight from the code base.
You're reverse engineering the blueprint that should have existed in the first place.
Yes. Then you move to phase 2, understand.
Because documentation isn't enough on its own.
Well, documentation is great, but a static blueprint doesn't tell you how a building actually behaves in an earthquake.
That makes sense.
Understanding goes a step further by building contextual intelligence. This is where you map those dependencies we talked about.
The spider web.
The spider web. You analyze the business rules embedded in that code, and you identify fragile or redundant logic.
So you really get to know the system.
Yeah. If we connect this to the bigger picture, this phase is what answers your most crucial strategic questions. It tells the CTO which components are tightly coupled, or where are our highest risk integration points.
You're figuring out which walls are load-bearing before you start swinging the sledgehammer.
You resolve the unknowns before you touch anything, which leads seamlessly into phase 3. Modernize.
The actual
The controlled transformation. Because you have documented everything and because you deeply understand the context and the dependencies, you can now refactor or replatform the application with absolute confidence.
The execution just becomes predictable.
Entirely predictable.
Okay, conceptually, that makes total logical sense. Document, understand, modernize.
It's a solid framework.
It is, but I have to play devil's advocate here for a second.
Please do.
Manually executing an archaeological dig across 10 million lines of spaghetti COBOL code. I mean, that sounds practically impossible.
Yeah, manually. Yeah.
It would take a human team 20 years. The playbook says we use AI to do this. But when I hear AI-assisted migration, I immediately think of AI hallucinations.
Which is a very fair concern.
If a large language model can't write an email without occasionally making up a historical fact, how on earth can a CIO trust an AI to rewrite a bank's core ledger without injecting catastrophic errors?
That is the most important pushback you could offer, honestly. And it's exactly where Code Aura's specific architecture comes into play.
Okay, tell me how they avoid that.
Well, you're absolutely right. Manual execution of this framework at enterprise scale is impossible. And blindly trusting a generic generative AI with mission-critical code, that is reckless.
Yeah, you can't just throw ChatGPT at a bank.
No. Code Aura doesn't just read code like a human or guess the next word like a typical LLM. It parses the underlying syntax deterministically.
Okay, what does that mean in plain English?
It means it builds what's called an abstract syntax tree.
An abstract syntax tree.
Yeah. Think of it like mapping the central nervous system of the software. It mathematically diagrams every single variable, every data flow, every logical branch.
Wow.
It's not guessing. It's structurally proving how the code behaves. So in the document phase, it ingests legacy languages and translates them into structured, human-readable formats instantly.
And accurately.
Completely accurately, because it relies on the structural DNA of the code, not on probabilistic guessing.
Oh, wow. So it's not writing a summary based on vibes.
No vibes involved.
It's translating the actual mathematical logic into plain English.
Precisely. And then in the understand phase, it takes that verified map and makes it dynamic.
Dynamic how?
Code Aura generates visual dependency graphs. It maps how data flows from an ancient database all the way up to a modern web interface.
That sounds incredibly useful.
It is. But the most powerful capability here is that it allows teams to query the systems conversationally.
Wait, like chatting with the code base.
Basically,
Giving your massive enterprise system its own ChatGPT interface.
yes, but grounded entirely in that verified mathematical map we just talked about.
Okay, so it can't hallucinate.
Right. A developer or an architect can essentially ask the AI, hey, if I change this specific regional tax rule in this COBOL module, what downstream systems will break?
That is wild.
And the AI, because it has mapped the entire structural nervous system of the enterprise, can tell you exactly where the cascading effects will happen before you write a single line of new code.
That completely eliminates the touch a string and the web shakes problem.
Exactly.
You know exactly what will shake before you even touch it.
And that makes the final phase, Modernize, incredibly safe. Codora provides AI-assisted migration, taking that legacy code and transforming it into modern stacks like Java or JavaScript.
Without breaking it.
Right. Because of the rigorous, deterministic work in the first two phases, it guarantees that the original business logic is perfectly preserved. It's a closed-loop system.
A closed loop.
The documentation informs the understanding guides the modernization, and the modernized code then updates and reinforces the documentation.
So zero institutional knowledge is lost.
None. Zero.
So what does this all mean for the bottom line?
That's the real question for the executives.
Because technical elegance and AI automation are fantastic, but if you're listening to this right now, you have a board of directors to answer to.
You need numbers.
Right. How does a structured AI native approach actually translate to the executive dashboard?
It translates directly into financial predictability and strategic agility by totally eliminating the rework cycle.
The rework cycle. Explain that.
Think about the traditional migration scenario. You deploy a new system, things break due to unforeseen dependencies, right?
Yeah, the spider web shakes.
Exactly. Then you have to pull your best engineers off new product development just to patch the old system.
That's expensive.
Timelines stretch out for 6 extra months, your budget doubles. By knowing exactly what will happen before you execute, you eliminate that entire rework cycle.
You just get it right the first time.
Right. We are talking about saving millions of dollars in cost overruns and preventing massive revenue hits.
You stop the bleeding,
Yeah.
basically. And you shift modernization from being this dreaded defensive IT roadmap item into, well, an offensive business driver.
It becomes a competitive advantage.
But beyond just cost savings, the playbook emphasizes massive regulatory pressure, too.
Oh, it's paramount. You have to consider these strict compliance frameworks.
Like what?
Well, you've got Basel the FIF, which is a massive set of global banking regulations dictating capital requirements and risk tracing.
Okay.
You've got HIPAA in healthcare, or PCI DSS for payment card industry standards.
Right.
Regulators do not care if your system was built 30 years ago. They demand to know exactly how consumer data is processed, routed, and protected today.
And a fragmented, undocumented legacy system is a massive compliance liability.
It's a ticking time bomb.
Because if the auditor sits down and asks how a specific piece of financial data is handled, and your answer is, well, the guy who wrote that table retired to Florida in 2018.
You are going to fail the audit immediately.
And the fines for failing those audits are astronomical.
Massive fines. But with a structured AI native approach, you have complete instant visibility.
Because you have the map.
Right. You can prove to regulators exactly how logic flows through your systems. And this raises an important question for enterprise leaders.
That's that.
Are you still viewing modernization as a painful, periodic disruption? Like something you just try to survive every 10 years?
A lot of them do.
But with this kind of AI-driven visibility, modernization becomes a continuous, repeatable capability. It becomes an operational muscle.
A muscle, I like that.
You can respond to regulatory changes faster, launch new products quicker, adapt to market shifts, all without the anchor of technical debt holding you back.
It's the difference between merely surviving your IT infrastructure and actually weaponizing it for growth. If we bring this all together, the core message for you, the enterprise leader tuning in, is that the trade-off between speed and risk is a myth.
It's totally false.
It's a false dichotomy born entirely out of a lack of visibility. By prioritizing clarity, control, and structure over blind acceleration, you just don't have to choose.
You really don't.
By using frameworks like Document, Understand, Modernize, and powering them with AI-native platforms like Codora that actually map the mathematical structure of your code, enterprises can move faster because they're moving safer.
You eliminate the guesswork.
You preserve your vital business logic, and you finally free your teams to innovate instead of constantly patching holes in a sinking ship.
It's about engineering a process that guarantees both stability and velocity.
Which leaves us with a final, somewhat mind-bending thought to ponder before we wrap up.
Oh, I like where this is going.
If AI platforms like Codora can systematically document, deeply understand, and flawlessly translate decades of messy, human-written legacy code, and do it significantly better than the humans who inherited it, what happens to the very concept of legacy code in the future?
That's a great question.
If we have AI continuously maintaining this closed loop of understanding and modernizing, will the systems we build today ever actually become legacy?
Maybe not.
Or will AI's continuous modernization loops make the entire idea of an outdated black box system completely obsolete?
It's a whole new world.
It really is. Something
It
to
is.
think about the next time you look at your IT roadmap.